Hello, Nikki Does here on the squeaky bench. Hear the squeaky bench? Well, today we have a sad situation because this shaft is out of a 25 millimeter travel Mitutoyo indicator, and it is, as I would have said when I was a kid, bented. It's bented. So you can see it bented down at the bottom a bit as I rotate this. So I wanted to straighten it, and I thought, what great time to show a video about how to straighten a bented shaft, particularly something that's fairly precision. So I've got magnetic base here with its funky arm. This is an Amazon purchase. It's quite cheap. And then I have something that's not quite as cheap. I have a Tessa dial indicator on here that's normally used. We normally chuck it up in the CNC machines, but I happen to have it here, so I'm using it. And this is definitely not a precision drill press. It's a delta, but rebadged from someone. But I have put a very nice Jacobs chuck on it, a J33 taper chuck on it. And the chuck is going to be nice and true. You can see here when I wobble the spindle back and forth, you can see quite a bit of, an incredible amount of wobble on there. But if I come up here and I've already taken the belt off the drill press, and if I just rotate this, you'll see quite a repeatable deviation here. This is in millimeters. So quite an appreciable deviation here as I rotate this around, and you can see me rotating it around. So it's quite repeatable. And if we were to move this down further on the shaft, what I'm doing now is trying to find where the bend starts. So let's start by moving it up a bit more on the shaft. Bring it out a bit. There we go. Let's see if it's still quite so bent. And it is. That's not bad, though. Here we're talking about, that's 0.2 millimeters, 0.1 millimeter per division. So that's not too bad up here. I would actually say that that's, so if we go even higher, let's see if we go way up to the top of the shaft. Because we don't need perfection for this. This is for a digital indicator. We need this so it slides smoothly in and out of the, so it's probably half as much. So that, who knows, that could be the run out of the chuck. Let's see if we can get on the chuck easily enough. Let's look what our run out of the drill chuck outside is. Now, yes, I know this is not precision, but as I'm trying to say, it really isn't something that we need it to be an ultra precision job. I don't know that I'm touching the chuck. That's a little better. I'm gonna have to put some tightness on here. Yeah, there we go. Focus. Yeah, that looks like it's run out on the chuck. All right, so let's go back down. What we need to do is find out where the bend starts so we can, and what axis around the polar axis of this part is bent. Poor little part. Now let's get this indicator tooled up here to the right spot. I believe, because I know how far it extended from the bore on the sleeve, I believe that's about where it's going to be. So let's see if we're still getting, we have to touch it. There we go. Yeah, see, we're still getting about what is the chuck run out. And there's a line right there that you can probably see where the finish of the shaft changes a bit, and I think that's where it extends. So that's not bad. Now, watch this. This is the whoa time right here. This is where you say, whoa. I want to hear an audible whoa. When this video premieres and millions of people watch it, I'm going to be listening. That reminds me of a story. When I was in college, The Simpsons were on, and in my dorm floor, when there would be a funny thing in The Simpsons, everybody on the floor you'd hear this cacophony of chuckles. So you knew that was a funny show. Well, at least for all these engineering guys, they all thought it was funny. So this is quite out. So this is where you're supposed to say the collective whoa. All right, let's see if that buries the indicator. Whoop. Yeah. It's beyond the range of the indicator. All right, so that's how far that is out. So there's definitely a bend, and I know it starts right up about here. So it's going to still be out right about there. Not too bad, but it's still there. And if we come up a little higher, it should just be the run out of the chuck. Is it touching? Yeah? Okay. Well, that's not bad. So what I'm going to do, this is not sponsored by this video. It's Sharpay. Sharpay. So I'm going to put a mark right about there. And then the other thing I'm going to do is, if you can't see it, I'm going to come back down on it, and I'm going to put a mark on where the, you can get these indicators, by the way. You don't have to get a Tessa. You can get these indicators on Amazon and everywhere else, and the magnetic base. And I'm just, like any tool, even if you're not some sort of machinist and everything else, this stuff is so cheap now. Even moderately good stuff is so ridiculously cheap that you kind of should, if you're into this kind of stuff, you should really just have something just so you have it for silly little jobs. You never know when you have it and when you need it, and if you have it, you'll use it. So right here, I'm seeing the maximum. Whoop, forward. Let's get the chuck in there a little bit so you can probably see it. So I'm turning it clockwise, counterclockwise, clockwise, counterclockwise, clockwise. So what is that? 1.0, 0.10, 0.01. That seems to be the maximum. So what I'm going to do is get right at the max, take my marker, come around the back side, right where that ball touches right there. I'm going to do this without the camera sitting here, but I'm going to make a mark on the back side right there. So let's see. And that'll tell me the axis that's closest to the ball. And of course I know where the bend starts because I've got my mark on there too. So the next part is really not all that elegant, and that's going to be me putting it in a custom, not custom, but purpose-built work-holding device, we'll call this. The key operative part here is device. We're going to put it in device, and we're going to put a piece of tubing over it, and we're going to give it a little little tweaky, and then we'll come back and see how it turned out. So I'm not going to show this part because it's cringeworthy. I think that's the proper term. It's cringeworthy how inexact my inexactitude will be when I do this. So here we go. Okay, so through the magic of hitting pause, I put this in the vise, and I have to tell you, for those of you, so I'm in North Carolina, and from those of you who are Gamecocks in South Carolina, I used Mary's school's rally towel where they played the Vanderbilt Commodores, and you can see that I've turned the rally towel into the appropriate use, which is just a shop towel. So this is reduce, reuse, recycle. This is just one step short of throwing it away. Sorry, Mary. We think North Carolina is the real Carolina. So there's my little hoo-yah plug. All right, so let's see what we've got after I so artfully pulled on this thing. Could it be that good? No. I've buried the needle. All right. Well, we've gotten better. We're not burying it quite so badly now. Did I go too far or not? This time I've gone too far. Let's see here. No. Nope. So that's where we need to be. My mark is worn off from all my handling, so I'm going to remark it. I mean, it's a chromed rod here, and it is stout. I mean, I don't know how somebody bent this, but whew, it is. It takes some pull to get this thing to bend a bit. You really can't tell how far you're bending when you're pulling like that. So I did not want to go too far. All right, but that's still a lot better. All right, pause again. Okay, and once again, through the magic of pause. Boy, that doesn't seem like I did too much to it, does it? You know, you're always afraid. It takes quite a bit to bend it, and I bounce it just a bit. I mean, it's still better. So let's see if that's the... That's the farthest in, so let's get that down to 0 as best we can. And it wasn't really 0, was it? All right. So we're still talking 0.3 plus millimeters out. Oh, it looks like I did go too far with it, didn't I? Yeah, I think I went a little too far. This time I've gone too far. Peter Gabriel, I think, said that. All right, one more time. All right, so I gave it another little tweaky, and now we're chucked up again. Let's see what we got now. Well, look at that. Would you look at that? That does not look so bad. In fact, that about 0.1 or 2 millimeters is where I think the chuck runout was sitting. So let's see what we got for chuck runout. Turn it up here. I mean, so let's see what this is used in. Pardon me while I get it out of the chuck. Let's go over and take a look at what this gets used in. Go through the mess that is my shop. This goes in a Mitutoyo absolute indicator. And here it is with the sled portion that goes up and down, and that measures the distance. And it's a pretty simple device in terms of its construction. There are 2 circuit boards in there. We'll take a quick peeky at that. I'm not going to show you me unscrewing 4 screws. Magic. 4 screws out. Took the spring off. That's the carrier. And you can see there's some Mitutoyo oops going on in here. I have to find my tweezers for this. Here they are. So they had to put a washer in here for some reason. If you look, there's a washer on the top end of this, but not on the bottom. So this is not something I would be used to seeing from Mitutoyo. And then again, this is the sled portion. And if somebody tells you it's not a vernier caliper, it is a vernier caliper, but it's a capacitive vernier caliper. And you can see the vernier portion. The vernier is the difference in numbers of pads that are on this side are little capacitors versus the difference on this side. And you'll see that the lines here and here do not line up. So it looks at the difference in capacitance between this side, and the ratio of these two would tell how far apart it is. And this one is absolute, so whenever you turn it off and turn it on, it knows the capacitance of all these. So that's a pretty sweet setup when you think about it. And there's the other side that reads it. That's the electrode of the capacitor. And then the other side of this board, which I really don't want to take out because it's got the zebra stripe rubbery thing that connects this board to the LCD. And I don't know why, but it seems like when you take those apart, you have a high chance of it not going back together very well, and you'll lose some segments on the LCD and stuff. So why would I mess with that? There is a small piece of metal that is staked in here that grounds the whole assembly to the board, because you do need that for the capacitance to be accurate. But for now, we're just going to set that back in. I guess I'll have to either hope those washers stay where they're supposed to stay as I flip this, which they usually do. And if they don't, I'll have to put them in myself. All right, and then as I said, I took the spring off. I didn't say anything about that, but the spring hooks on here, and it hooks on there, and that's what pulls this down. This rod goes in, and we're about to see if the rod is true now. So this rod goes in. You know, interesting. It's unfortunately, it's still a bit tight here at the end of the travel. I wonder if I got it with the wrench right there. It feels like I may have. So it's really smooth here, but right at the end of travel, it's not so smooth. So I may have to do a little more tweaky with that. I'll do that off camera. Well, in any case, that's almost a complete repair of this Mitutoyo dial indicator. I, again, don't have any idea what would have, not dial indicator, indicator. I don't have any idea what would have done such an awful thing to it and destroyed that end of that rod and bent that so much. But in any case, thanks for watching.